Hello everyone. So this video is regarding one of the question that was asked to one of the BMATH student who went for interview this year. Okay, so current this interview process which is ongoing. Okay, so yes, there are overall 24 students who have cracked BMATH and BStat written together, and yes, now they are going for the interview process. So and also there are 12 students who have qualified for the CMI undergrad. So yes, now they are sharing the questions that were asked in the interview process. So we will share as many questions after the interview is done, at ISI, Kolkata as well as Bangalore, and yes, and also as the final list comes out, so we'll post all the names, and yes, I congratulate to all who have cleared the written and as well as who have got into CMI undergrad course. So yes, now talking about the question. So the question is a puzzle. Okay, so this is one of the question which I found very interesting. So the other questions are related to like the normal, number theory, combinatorics, geometry, calculus. But this one was a puzzle. Okay, so now the puzzle is like okay. Let's go to the board. So let me explain there. Yeah, so the puzzle is as follows. So it says that there is a building, okay, and the building has 100 floors, and now you have two stones, okay. So sir just a second. So yes, now there are 100 floors, and yes, so now 100 floors, and you have two stones, okay. Now you have to check the maximum floor from where if I drop the stone it will not break, okay. And so you have to figure out the minimum number of steps required to do this. So suppose when you are throwing a stone from one of the floor to check whether it breaks or not, because you have two stones, right? So you can throw the stone, suppose you are throwing the stone from the 10th floor to check whether it breaks or not, okay. If it breaks, then you cannot use the stone again, so it's finished. Then you have one stone left, okay. And then you have to throw the other stone, and again if it breaks, then you are done. You have to finally determine, you have to surely say that is the maximum floor from where if I throw the stone it will not break, okay. So you have to basically test it, right? So what the question is that the minimum number of steps you can do this. But if it wasn't asked that like what is the minimum number of steps, then what would you basically do? So you would basically have done a very simple process of elimination, that is like suppose some kth floor, okay, so some kth floor is there where that is the maximum, where the stone if you throw it will not break. So after k plus 1 to 100 the stone breaks, okay. So you know that like from 1 to kth floor the stone doesn't break. So you go to the first floor, you throw the stone. If k is not equals to 1, it doesn't break. Then you go to the second floor, third floor, okay, and so on and so forth. So the first floor it breaks. Then you go to, you know that the floor lower to it is the maximum floor. Like in this case, at the k plus 1th floor it will break, right? So then you know that the k is the maximum, such that the kth till the kth floor, if I throw the stone it will not break, right? So it requires how many steps? It's requiring k plus 1 steps, right? So that's a very basic approach, but that's like, now see, this will work when like this will give you a very minimum value when I mean by any chance k is very small, like k is the first floor, second floor, third floor. Okay, but what we have to do, we have in any scenario we have to determine. Okay, so we can't like assume that k is very small and go with the help of this. Okay, so what should one do? So the idea here is that we should like throw the stones from some arbitrary floor, okay, and see that whether it breaks or not. So suppose like an arbitrary floor, like the kth floor, I just threw one of the stone and it broke. Okay, so then what do I know? That like suppose this is some ith floor. So the previous I threw it from the ith floor, it did not break. Okay, then after some floors I threw it from the kth floor and the stone broke. So then what do I know? I know that then from I to k minus 1th floor there is some floor where I'll get the maximum number, the floor number from where I throw the stone, it will not break. Okay, so there what happens is that we can get the idea that so the solutions is all over the internet, so I don't want to take any credit for the solution. There is a very nice video representation by TED, the link of which I have also given in the description. You can go and check it out. So here I'll explain briefly the idea. So the idea is that this, suppose you are first throwing it from the nth floor. Okay, so now the nth floor you went and threw the stone, and if it breaks, then what do you know? You have to like then check the floors from 1 to n minus 1, just how we described in the very first step, that we can go first floor, throw the stone, second floor, throw the stone, till the n minus 1th floor we can go and throw the stone, and whichever floor the stone breaks, then we know that the floor below that works, okay, as the maximum floor. So if I throw the stone first time from the nth floor, then I can do one thing, that is I can make sure that I will not exceed n floors, okay, or sorry, n steps. How? So here you see that suppose if it breaks at the nth floor, so I required one step to throw the stone from the nth floor. Then if it breaks, then I know how many steps will I require, because there are n minus 1 floors, so max I will require n minus 1 steps. So you see n steps again, right? So now again if I go and throw it from the next, like I have to now next choose my floor where I'll be throwing the stone. So if I want that I'll not exceed n floors, so from where can I throw the stone? So I can throw the stone from let's say like think like this, that from that floor if I throw the stone and it breaks, okay, so then how many steps am I having? 2 steps, right? So I'm having 2 steps because I threw it from that nth floor and then from that next floor, and it breaks there, and then I have to check all the floors from n plus 1th floor to that that floor, like let's take it's the jth floor, okay, so that j minus 1th floor I have to check. So that means if I don't want to exceed n floors, so what I'll do, I'll keep n minus 2 floors there in between, okay. So here that means so here I have like first floor to n minus 1 floor, and then here next I'll be keeping like between, I'm talking not inclusive, the jth floor and the nth floor are not included, so in between I'll keep n minus 2 floors, okay, and so here in between I have, so from the first floor till the n minus 1th floor I have n minus 1, n minus 2, and then how many floors should I keep? N minus 3, because if the third time when I throw the stone, if it breaks, I'll have to check n minus 3 floors, because then I'm done with 3 steps and n minus 3 more steps, okay, and so on and so forth. Like this I'll just continue. And so what equation am I getting? So there are total 100 floors, right? So what I am getting is basically the equation that is n, okay, plus n minus 1 plus n minus 2 dot 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 plus 1, and that should exceed 100. Okay, so this equation should exceed 100. Why? Because you can very well see that, like, so n is the first floor from where I am throwing the stone, okay, so that's the nth floor. So then what do I need? Like at the nth floor, as I explained, that at the nth floor if it breaks, then I have to check the n minus 1. So I'm done with one step and then the n minus 1 steps. So under n steps I'll be able to cover up. I'll be able to surely tell which floor works. And then if that floor doesn't work, what do I need? I need another one more chance. So 2 chances gone. So then n minus 2 chances left. So I'll be going n minus 2. I'll be keeping from the next floor where I'll be throwing the stone. In between I'll be keeping n minus 2 floors. Okay, and so that means the jth floor will be n plus n minus 1, because in between there are n minus 2 floors. So that means n plus n minus 1, that is 2 n minus 1. Then the next floor will be what? I need to keep n minus 3. So that means I'll add n minus 2 with it, right? So that means I'm adding n, so n, then n minus 1, then with it n minus 2. So that's the floor, right? So what am I getting? 3n minus 3. That's the next floor from where I am throwing. So suppose if 3n minus 3, that floor I throw the stone and it breaks, then what do I have to check? I have to check the n minus 3 floors in between. And so I am done with 3 steps, and I have to check more n minus 3 steps at max. So that means I'll be done with n steps at max. So like this the idea goes on. Okay, I keep on going on like this, and till there are like only only one, the next floor I have to check. So otherwise, like the difference, what happens, you see that the difference decreases, right? First I have a gap of n minus 1 floors, then n minus 2 floors, and then n minus 3 floors, correct? And so the gap decreases, correct? And so you see that, like, the first time I am throwing it from the nth floor, the second time I am throwing it from the if it doesn't break, then I am throwing it from the n plus n minus 1th floor. If it doesn't break, then I am throwing it from n plus n minus 1 plus n minus 2th floor. Like this, at the very end, from where can I throw it? I can throw it from n plus n minus 1 plus n minus 2 dot 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 till 1. Okay, so it decreases gradually. So from that floor I can at max like throw the stone, correct, if I proceed this way. And now I have to look for which n this sum becomes greater than equal or maybe equal to 100. So it's basically becoming greater. So so basically n, if you see, n equals 14 works. Okay, so for 14 I think the sum is coming out to be 105 and it's exceeding 100. So that means basically, like, and n equals 13, again you are not getting, like, the sum is not greater than equals to 100. So for the first n which works is n equals 14. Okay, for this we cannot go for n equals 13, because by this way if we go, then we might, if suppose the 100th floor is the maximum one, then we may not be able to reach the 100th floor if we go like that. Okay, so n is minimum, like the n which works for this equation, this inequality is 14. So that means if we start from the 14th floor, then we would be surely able to tell in 14 steps. Okay, and yeah, so that's the answer of the puzzle. That is like at max I need 14 steps to tell with the help of these two stones and the given condition that which is the maximum floor number from where if I throw the stone it will not break. Okay, so like how is the sequence going? Just think about it. So first the stone is being thrown from the 14th floor. Okay, if it doesn't work, then we are throwing it 14 plus 3, so that is basically 27th floor. So 14th floor, then 27th floor, and then if it doesn't work, then we are adding what? We are adding n minus 2, so which is basically 12. Okay, so 12 means then 39. Okay, and then 39, and then we will be adding 11 with it, so that means 50th floor. Okay, and then we'll be adding 10, so 60th floor. Okay, and then we'll be adding 9, so 69th floor, and then we'll be adding 8 with it, so 78th floor. Right, sorry, we'll be adding 8 with it, so 77th floor. Okay, and then we'll be adding 7, so 84th floor, and then we'll be adding we added 7 here, so 6, then 90th floor. Correct, so there's no space, just think like 90th floor. Okay, like I'm dropping the stone and it's not breaking, so this is the sequence it's going. 90th floor, and then if it doesn't break at the 90th floor, we added 6, so then we'll add 5, so 95th floor, then we'll add 4, so that means 99th floor, and then you see that if we add 3 it doesn't make sense, so we have to like next drop even from the 99th floor. It doesn't if we throw and it doesn't break, then we have to check the next floor, which is the 100th floor. Okay, and yes, so the number of steps at max you need is 14. Okay, and yeah, so that's the answer of the puzzle. And again I'm saying that I haven't made this solution, so I won't take any credit for the solution. Just wanted to discuss the solution, might be helpful to many students who are preparing for the exam or going for the interview. So all the best guys who are still haven't given the interview, and also who have given the interview, hope for the best and don't lose hope. So thanks for watching, and keep watching and keep learning, and see you in the next one.